All right, I finished my general announcements, the highlights of which is today is the last day to turn in the pink review packet and make up the test from 2 days ago for on-time credit. Students will have an additional week beyond that, but at that point, it's 10% off. The no packet that we're in right now will culminate on October 25th. That's when we take our next test. The week after, we'll be reviewing and taking a quarterly assessment for marking period 1. Now, students were already given time to complete the multiplication at the top of page 5. Today is essentially going to be me going through tons of practice problems, 18 to be exact. Students are encouraged to interrupt me at any time and ask questions, but the hope is that we will have time at the end of the period for students to work on homework 15. Okay, so with that being said, I'm going to follow the directions. It says use the laws of exponents to simplify each expression. Okay, and I'm going to zoom in on each of these. So if you are multiplying similar bases, you would add their powers. So you have 5 plus a negative 2, which is positive 3. That is your final simplified form. So the first one, pretty quick and easy. Okay. I'll zoom out just so that people can see one while I do the next one. Now with the next one, if you have a whole bunch of stuff in parentheses, and then you have a power, an exponent on the outside, that exponent needs to be applied to everything inside the parentheses. Okay, so that 6th power gets applied to the 3. But it also gets applied to the m to the 4th. And remember, if you raise a power to another power, you have to multiply the powers. That dot between the 4 and the 6 means multiplication. Marvin, you with us? You want to help me out, Urim? Tap your partner for me. You with us, sir? All right, let's get our head up. I appreciate it. That 6 is also going to apply, thank you, Urim, to the n to the 5th. Remember, if you raise a power to another power, you multiply the powers. Now, I would not expect any of you to know 3 to the 6th off the top of your head. So for that one, you're absolutely allowed to use a calculator. Okay, remember, that's what our little caret symbol is for. 3 raised, it's that little arrow button underneath the clear button, okay, to the 6th, and you get 729. Okay, so this is 729, and then the m, 4 times 6 is 24, and the n, 5 times 6 is 30. So this would be your final answer. Questions on number 2? All right, number 3 is a lot like number 2. You've got a power on the outside, and it needs to be applied to everything on the inside. It needs to be applied to the 8, so you get 8 squared. It needs to apply to the x to the 3rd, so you get x to the 3rd times 2. Remember, a power raised to another power, you multiply powers. Okay, now 8 squared is something I would expect you all to know, and it's not 16. What is 8 squared? 64. Thank you. 8 squared is 8 times 8, which is 64. So we have 64 for the 8 squared, and then 3 times 2 on the x is x to the 6th. Again, slow me down, stop me if you have questions, because this is basic. I'm just going to keep pushing. We're getting through 18 practice problems. Okay, I genuinely believe this is the type of thing where the more you get exposed to it, the better it's going to make, the more it's going to make sense. Now, everyone in the room should be able to tell me almost instantaneously what number 4 simplifies to. It simplifies to 1. Anything to the 0 power is 1. That's a rule in mathematics. And I promised you, and I'm going to hold to that promise, next week on your CFU, I am going to put a problem like that. I'm going to put a whole bunch of crazy gibberish that looks scary, but then I'm going to raise it to the 0 power. Okay? So no thought needs to go beyond that once you notice it's being raised to the 0 power. Anything to the 0 is 1. Now, the next one, number 5, I'm going to argue there's a couple different ways you can approach this. So I'll show 2 different ways of doing it. My preferred way is all at once, which I won't blame you if you don't like my way. What I remember is that if you are multiplying similar bases, you add their powers. So I'm going to add the numbers on the top, -5 and 10. But when you divide by a similar base, you have to subtract that. So you'd be subtracting the 4. So if I was showing my work, here's what I would write. I know the -5 and the 10 are going to be added, but then because I'm dividing by 8/4 on the bottom, I have to subtract the 4. So this is doing it all in one step. But I'll show another way just in case people aren't comfortable with this. -5 plus 10 is 5, and 5 minus 4 is 1. So we don't ever really bother writing a to the 1. If you really want to write it, that's up to you. But in general, we just write a. The 1 is automatically implied. Now, if you don't love my way of doing this all at once, here's another way you could do it. On the top, you have a to the -5 plus 10. And I'm not going to work with the bottom yet. I'm just going to simplify the top. -5 plus 10 is +5. And now you have a to the 5th over a to the 4th. And again, when you divide bases that are similar, you subtract their powers. And 5 minus 4 is 1. So you end up with the exact same answer, but you get there with a little bit more work because you're doing it one step at a time instead of the way I preferred, which is all at once. Okay. So now we're getting into a slightly more complicated example. Okay. We've got 2x to the 6th over 5x raised to the 3rd. Now, just like we saw before, that power needs to be applied to everything on the top, but it also has to be applied to everything on the bottom. Okay, it's got to be applied to the 2, it's got to be applied to x to the 6th, it's got to be applied to the 5, it's got to be applied to the x. Okay, so I'm going to do this one step at a time. On the top, we have 2 to the 3rd, and we have x to the 6th to the 3rd. And when you raise a power to another power, you multiply powers. On the bottom, we're going to have 5 to the 3rd, and we're going to have x to the 3rd. Now, here's where I'm going to do a few extra steps all at once. Okay, let's talk about the x's for a moment. On the top, you have 6 times 3, which is 18. So you have x to the 18 divided by x to the 3rd. Remember, when you divide similar bases, you subtract their powers. So, folks, what is 18 minus 3? That's something that thank you. I need the class participating here. So we've got 15. So this is going to reduce to x to the 15th. I'll show separately. I'll kind of show separate work here for what I just said. This is x to the 18th over x to the 3rd, which means you do 18 minus 3. That's where the 15 is going to come from. Now, for the numbers, again, you can do that in your calculator. Okay, 2 to the 3rd is 8, and 5 to the 3rd is 125. So you end up with 8x to the 15th all over 125. Okay, and again, I got the 125 and the 8. Okay, if you want to use your calculator, 2 to the 3rd and 5 to the 3rd, that's where the 8 and the 125 came from. Okay. Questions on problems 1 through 6. Believe it or not, we're already a third of the way through the class because there are 18 problems I want to get through with you all, and we've done 6 of them already. Okay, go ahead and turn the page. Okay, these first 2, I think, are going to go pretty fast. When you are dividing, although this one does have a little bit of a trick to it, when you are dividing, remember you subtract your powers. So you get 3 minus 5. What is 3 minus 5? -2. That's the problem. Okay, you cannot circle that as your final answer. When you are simplifying exponents, your final answer, bless you, should not involve negative powers. So I'm going to take that -2 and I'm going to flip it. I'm going to move the x squared to the bottom. That way I can write this as a positive exponent. That is how you would write out your final answer. Now, our answer would have been different if the original problem had been flipped. So now I'm going to switch to red ink because this is not the problem. Okay, this is not this thing. If it had been x to the 5th over x to the 3rd, well, then you would just have 5 minus 3, and you get a +2, and you'd be done. That would be your answer. If it was x to the 5th over x to the 3rd, then fine. When you get to x squared, you're done. But it's not. In this case, it's x to the 3rd over x to the 5th. So when you subtract, you get a negative, and that means you have to do an extra step. You have to flip it to get rid of the negative power. Okay? Next one, even faster than the last. A power raised to another power means you multiply powers. So you just get x to the 21. Okay, and by the way, in case for some reason, if this isn't totally clicking, remember what x to the third represents. X to the third means x times x times x. And then when you take x to the third and you raise it to the 7th power, what it means is take that thing and multiply it by itself 7 times. It's going to take me a minute to create, but at least with technology, I can do it a little faster than by hand. That is what x to the third to the 7th means. It means take x to the third and multiply by itself 7 times. And if you do that, you end up with 21 copies of x. Okay, that's where the x to the 21 comes from. But the shortcut is to know, oh, if I raise the power to another power, just multiply the powers and I can be done. Okay? All right. Next one requires a little bit of a background subskill. If you recall, in a previous unit, one of the things we had to learn before we did slope is, can you reduce fractions? I would argue it's the same thing coming up here. We need to know how to reduce this fraction. Can anyone name a number that divides both 6 and 18? 2 works, but there's a bigger number. 3 works, but there's a bigger number. Yeah, 6 and 18. What number divides both 6 and 18? I'll give you a little trick. If 2 divides it and 3 divides it, well, then what's 2 times 3? That should also divide it. 6 is the biggest number that divides both. So if you divide the top by 6 and you divide the bottom by 6, this reduces to -1/3. That would be part of the process of reducing this thing. Now, in terms of the variables, that's something else. So this would reduce to -1/3. And then for the R's, you have 2 minus 2. And for the S's, you have 5 minus 1. There's kind of like a hidden 1 there because there's only one S on the bottom. Now, here's another side note. This right here, and now I'm thinking I want to reduce this so it's not in my way, so bear with me. There we go. Okay. All right. This right here is R to the 0. But what is anything raised to the 0? What's anything raised to the 0? 1. Okay. So when we're simplifying this, you have R to the 2 minus 2. Well, 2 minus 2 is 0, so you have no R's left. And R to the 0 is a 1. So you can basically just ignore it. Act like it's not even there, because anything times 1 doesn't change. So our final answer is going to be -1/3 S to the 4th. Okay? So negative S to the 4th all over 3. Oh, yeah, I remember. Last class, this answer was really weird because the S and the 3, but in any case. So just to be clear, that is not a 5. I think that was what, I think last class some students might have been confused because my S kind of looked like a 5. But that's not a 5, it's an S. Negative S to the 4th all over 3. Questions? All right, so believe it or not, we're halfway done. We've done 9 problems. We got 9 more left. All right, I will warn you, some of these are a bit more complex. Okay, although I think 10, 11, and 12 are the hardest ones on the page. I don't know. Some people may think the last 3 are the hardest. All right, so next one, I'm going to zoom in a bit more just because I want to make sure everyone can see exactly what I'm writing. Now, for these, I'm going to do this a little more slowly. I'm going to do this a little more piece by piece. You have some stuff in a parenthesis with an exponent. This exponent has to be applied to everything. I'm going to do that first. Okay, I'm not going to do anything with the other parenthesis. With the other parenthesis, I'll just copy it. 4x to the 5th. I'm not going to touch that one yet. I'm just going to take the exponent on the outside and distribute it to everything. So I get 3 squared times x to the 4 times 2. Okay, remember, a power raised to another power, you multiply powers. Now, what is 3 squared? Don't say 6. It's 9. 3 squared is 3 times 3, which is 9. And 4 times 2 is 8. So this is what you have first set of parentheses. I still have not done anything with the second set. Now, to be clear, this is just a number. this is just a number, you're allowed to multiply those. That's what you're doing. 9 times 4 is 36. But then you have two exponents with similar bases. Now, let's be clear. This is not, I'm going to write this in red. This is not x to the 8th raised to the 5th. If you had x to the 8th raised to the 5th, then you have a power raised to another power. You'd multiply the numbers and you get 40. But that's not what we have here. What we have here is x to the 8th times x to the 5th. So what do we have to do with the two powers? Not divide. That's if you're dividing them. Not multiply. That's what I just said we're not going to do. We're going to add them. Exactly. If you are multiplying similar bases, they both have a base of x, then you add their exponents. So it's going to be 8 plus 5. Okay? So this is going to be 36 x to the 13th. That is your final answer. All right, I'm going to jump to the next one here. I'm going to do it in a very similar fashion as to what I just did. Whoa, that's weird. Oh, weird. No idea why that randomly jumped down like that. Yeah. All right. Let me zoom back in. All right. There we go. All right, for the next one, I'm going to do it in a very similar fashion. I notice an exponent that needs to be applied to everything inside this set of parentheses. So for the second set, I'm not going to do anything to it. I'm just going to leave 2x squared y alone. I'm not going to touch it. But I'm going to take the power of 3 and I'm going to distribute it. So in the other set, I have x to the 3rd times 3 and y to the 3rd. Now, 3 times 3 is 9. So we have x to the 9th, y to the 3rd, times 2x squared and y. Now again, if you have powers with a similar base, they both have a base of x, then you add them. And same thing with the y's. If you have powers with a similar base, you add them. By the way, this other power that I highlighted, what is that number that's not actually written? If there's no power right here, what's that power? Not 0. 1. Exactly. There's one y there. So remember, if you don't see an exponent, it's kind of like, well, you just have one y. Okay? So for the 2 is by itself. There's no other number to combine the 2 with. So my final answer is going to be 2 x to the, somebody fill in the blank. How many x's do I have? I have way more than 2. I got x to the 9th and x to the 2. What do you do with the 11? There you go. You add the powers. And how many y's? What's the y exponent going to be? 4, because 3 plus 1 is 4. This is your final answer. All right, and I'm going to do 12 yet again in a very similar fashion. You've got this exponent that needs to be distributed to the -3, the x to the 8th, and the y squared. I'm not going to do anything with the other parenthesis yet. I'll get to that later. So in the first set, we've got -3 squared, we've got x to the 8th squared, and we have y squared squared. Now, you all help me out. What is -3 squared? Or put it another way, what is -3 times -3? What is it? Not -9. That's actually why I asked. 3 times 3 is 9, but when you do -3 times -3, remember, negative times negative is positive. Negative times negative is positive. Positive 9. Okay, so -3 squared is 9. For the x, 8 times 2 is 16. For the y, 2 times 2 is 4. So this is what you have in the first set of parentheses. And now what we have are numbers that we can multiply, and we only have 2 powers that we can combine. You can't do anything with the x to the 16th. There's no other x anywhere. Combine it with. Okay, so the x to the 16 is just going to stay x to the 16. Okay, but 9 times 2 is 18. X to the 16 stays by itself. And then what do you do with the 4 and the 2 on the y's? You add them. So 4 plus 2 is 6. Your final answer on that one is 18x to the 16th, y to the 6th. All right. So now I'm going to put some folks on the spot here. See if they're ready for this one. Oh, why'd you do that? I mean, you're not wrong, but I'm going to hope people didn't hear you. Anaya, what is number 13 equal to? You got it. Kaden, what's number 14 equal to? You got it. Davian, what's number 15 equal to? Perfect. For anyone who didn't hear them, they all said 1, and they're all absolutely right. Every single one of those. Yes, it looks scary. It has a ton of stuff going on, but then when you notice, it's just a bunch of stuff being raised to the 0 power. So in every single one of these, you can just say equals 1, equals 1, equals 1. And I keep telling you, I'm going to give you a problem like that on the CFU next week on Tuesday. So if you're paying attention, that problem takes you 3 seconds. If you're not paying attention, well, then you might waste a bunch of time on it and feel like it's just another thing you don't know how to do. And you're wrong. You actually do know how to do it. You just had to be paying attention in class. All right. 3 more problems, and then we call it a day. Let me zoom in so we can see these easily. All right, so this one looks pretty complicated, but again, what I would stress is just take it one step at a time. This 5 is going to apply to everything in the numerator. It's also going to apply to everything in the denominator. So I'm going to do this one step at a time. And again, when you raise a power to another power, you multiply. So on the top, we would have a to the 6 times 5, b to the 6 times 5. On the bottom, same idea. We're going to apply that 5th power to everything on the bottom. So on the bottom, we have a squared times 5. We have b to the 8th times 5. Now, if we work out all of these multiplication rules, we've got a to the 30th on the top, b to the 30th on the top, and on the bottom, we have a to the 10th and b to the 40th. Still not done. Because what do you do if you have 2 powers that have a similar base? What do you have to do with those numbers, folks? When you're dividing, you subtract. Exactly. So for the A's, I don't want to go down that far. For the A's, we would have 30 minus 10, which is 20. And for the B's, what is 30 minus 40? Negative 10. Well, that kind of creates an annoying situation where we have another step because your final answer is not allowed to have negative exponents. So what we have to do is take that b to the negative 10th and flip it to the bottom. So our final answer is a to the 20th divided by b to the 10th. That would be your final answer because it gets rid of the negative exponents. Now, the next problem is going to be very, very similar to that one because, again, it's a fraction with a ton of different powers and an exponent. So I'm going to do this one very similarly. I'm going to take the 4, apply it to everything on the top first. So we have c squared times 4 and d to the 10 times 4. That's what's going to be on the top. But then on the bottom, I'm going to do the exact same thing. I'm going to distribute this 4 to everything down here. So we have c to the 8 times 4 and d to the 3 times 4. Now, if you work out those numbers, we have c to the 2 times 4 is 8, d to the 10 times 4 is 40, c to the 8 times 4 is 32, and d to the 3 times 4, which is 12. And then once again, we need to do our subtraction because we're dividing, okay? We have both of these numbers which have to be subtracted and these numbers which have to be subtracted. Can anyone tell me what is 8 minus 32? Because you always subtract the number on the bottom. What is 8 minus 32? It's got to be negative something because 32 is the bigger number. Negative 20, negative 24. So we have c to the negative 24. And then for the d's, what is 40 minus 12? Because again, you always subtract the number on the bottom. What's 40 minus 12, folks? Not 38. That would be 40 minus, there you go, 28. 28. And again, you cannot have a final answer with a negative exponent. So I've got to take that C term and flip it to the bottom. So my final answer is D to the 28th divided by C to the 24th. Questions? All right, last problem. Again, really, really similar to the last two that we just did, because you've got an exponent that needs to be distributed to a whole bunch of things on the top and a whole bunch of things on the bottom. I'm going to skip a little bit of work here. I'm going to just multiply the powers right away. If that's too much for anybody, just speak up. On the top, I'm going to have x to the 6th, y to the 15th. On the bottom, I'm going to have x to the 12th and y to the 6th. Okay, I kind of did all the multiplication all at once, but if anyone wants me to break that down more slowly, just say so. Now, again, we do the top minus the bottom. So 6 minus 12 is -6 for the x's. 15 minus 6 is 9 for the y's. But if you have a negative power, you have to flip it to the bottom. So your final answer is y to the 9th divided by x to the 6th. And with that, we're done. And it looks like I got you all 11 minutes. My goal was to get around 10, so we hit that goal pretty perfectly. Again, I would recommend that you use that 10 minutes, work on homework number 15. That's what's due next week on Tuesday. And it's excellent practice for CFU number 5 on Tuesday next week. Okay? So at this point, students should use the rest of the period to work on homework number 15, but it's the end of the recording. So thanks for watching. Have a good one.